bass in your face.
Day, sir. By the way, sir, I'm Uchigi Pearl Jam Bass Cream 2. Photographic rays, its nature and characteristic. A. Light. Light is one of a number of known form of radiant electromagnetic energy which travel in wave motion. Actually, there are other territories that explain the behavior of light. X quantum territory, but for our purpose, the wave territory is the only one considered. This form of energy travels at a speed of about 186 miles per second air, but they differ in wavelength and frequency. Wavelength is the distance from the craze highest points to the wave to the next succeeding craze, while frequency is the number of wave passing in a given point in a 1 second. The product of the two is the speed of travel. The speed of the virus radiant energy is constant at a given medium, but varies with other media. For example, the speed of light in ordinary glasses is only about two-thirds of its speed in air. Actually, it is only the wavelength that changes. Frequency remains constant. However, frequency is much more difficult to measure. Wavelength could be determined with accuracy. Hence, we identify a particular radiation by its wavelength. Wavelength is measured by the angstrom unit, or in terms or millimicrons, English system or measure, or nanometer metric system of measure, which is equivalent to 1 over 1 million of millimeter. The different energies in the electromagnetic spectrum are the following: cosmic rays, gamma rays, X-rays, ultraviolet rays, visible light, infrared rays, heat rays, Hertzian waves, and the alternating current acceleration. The energies that are capable of being recorded on sensitized materials are the X-ray, ultraviolet rays, visible light, and infrared rays. They are sometimes referred to as the four photographic rays of modern photography. The wavelength of X-rays is from 01 to 13 nanometers. Ultraviolet violet rays from 30 to 400 nanometers. Visible light from 400 to 700 nanometers, and infrared rays from 700 to 1000 plus nanometers. Actually, the wavelength of infrared rays extends beyond 2000 nanometers, but the longest wavelength that the present sensitive materials could record is only up to this limit. The Webster Dictionary defines light as a radiant electromagnetic energy that can be seen by the naked eye. The scientific definition of light is the aspect of radiant energy of which a human observer is aware through the visual sensation which arises from the stimulation of the retina of the eye. Light rays with a wavelength of 400 to 700 nanometers is referred to a visible light because it is only within this wavelength that the human eye is capable of perceiving. Those with shorter or longer wavelength are commonly referred as invisible radiation. Definition, all lights are visible. For this reason, that word visible is superfluous in that common expression. Visible light, what the eye cannot see, are referred to as radiation. Light energy has several effects on an object. It is either reflected, absorbed, transmitted, or converted. The verifying combination of these reflectance and absorption are what gives use the wide variety of colors which we are able to perceive at time. Other light are neither reflected or absorbed but is transmitted through the object. These transmitted light are light passing through the object and allows a viewer on the other side of the object to perceive the light waves. The final effect a radiant energy may have on an objective is to be converted to another wavelength. This conversion is known as luminescence. There are two types of luminescence, that fluorescence and phosphorescence. Fluorescence is the ability of an objective to convert one wavelength to another as long as the active energy source is irradiating the objective. In the phosphorescence, that objective not only convert the wavelength while being entered but continues to reflect the new wavelength for a period of time after the energy source is removed. White light. When all the wavelength between 400 to 700 nanometers are presented to the eye in nearly equal quantity, we get the sensation of precision of colorless or white light. If a narrow beam of white light is allowed to pass through a prism, it will bend the light of shorter wavelength more than those with longer wavelength, thus spreading them out into the visible spectrum. These are the colors of the rainbow: the red, orange, yellow, green, blue, indigo, violet. If we divided the wavelength of visible light 400 to 700 nanometer equal into 3, from 400 to 500 nanometer, from 500 to 600 nanometer, and from 600 to 700 nanometer, we will produce blue, green, and red colors. These are known as the three primary colors of light, as differentiated from the three primary colors of paints, the eyes, and coloring matters, which are the blue, yellow, and red. Additive color mixture. If we get three projects with beams of light projecting individually blue, green, and red, and have that three beams overlap over the other, we will note that the portion where the blue and green lights merge over the other, it will produce a cane color, the green and red light, a yellow color, and the red and blue lights, a magenta color at the center where the blue, green, and red light were combined in proper trio. We see white light in this aspect. Can yellow and magenta are known as their three secondary colors of light for practical purpose. White is the presence of all colors. White black is the absence of all colors of the absence of light. Subtractive color mixture. This time, the light beams of the three projector will be covered each with green filter, yellow filter, and magenta filter, and have the beams of light projected one over the other. The green filter will transmit blue and green light but absorb red from white light. A yellow filter will transmit green and red light but absorb blue from white light. Similarly, a magenta filter will transmit red and blue light but absorb green from white light. At the center where the three beams of light are merged together will produce black. In a simple term, yan is the complementary of red, yellow is the complementary of blue, and magenta is the complementary of green. The range of color which can be produced by subtractive mixture of three rays is quite large and make is possible the modern process of color photography which depends on the subtractive principle. Production of colors. There are a number of different ways in which color is product. One needed to know the variable quantities of colors so it will be possible to evaluate color as quality. 1. Absorption. The color of most ordinary objects are due to the fact that they do not absorb the same amount of light at each wavelength. 2. Scattering. The color of the blue sky is due to the scattering of light by the atmosphere. Variation in the density of the atmospheric gases act in such a way that they scatter light of the shorter wavelength at the blue end of the spectrum. Much more they scatter light of the longer wavelength of the red end of the spectrum. Thus the sky is blue when is the clearest and white when is less clear. Interference. Color can also be produced by interference of light waves in thin flame like in soap bubbles or a flame or oil floating in water. The light reflected from the top surface of such a flame undergoes a reversal or phase, but the light reflected from the bottom surface does not undergo this type of change. The phenomenon is also responsible for the color pattern known as Newton ring, which sometimes cause trouble in color printing work. Fluorescence. This happens when molecules of the fluorescent materials absorb energy at one wavelength and radiate it at another wavelength. Dispersion. Color may arise from difference in the reflective or bending power of transmitting medium of light of different wavelength. The rainbow is a good example of this phenomenon. Attributes of color. According to the modern scientific definition of color, it is not legitimate to ascribe color to an object, but only to the light reflected from it. Thus, any color perception has three characteristics, any one of which can be verified independently of the other two. These are hue, saturation, and brightness. Bending of light. When traveling in open space, light travels in starlight line. However, when light comes in contact with an object, it may be bended in the following manner. 1. Reflection is the deflection of bouncing back of light when it hits a surface. A regular reflection happens when light hits a flat, smooth and sandy surface. B. Irregular of diffuse reflection occurs when light is out of uneven but glossy object. 2. Refraction, the bending of light when passing from one medium to another. 3. Diffraction, the bending of light when it is a sharp edge of an opaque object. Kinds of objective as to how they behave to light. Transparent objective allows a fluorescent visible light to pass through them. That objective on the other side may be clearly seen. Translucent object allows light to pass, however diffuse is such that object on the other side may not to be clearly distinguished. In some cases, the object on the other side may be recognizable, but sharp detail and outline are absorbed. 3. Opacity objectives. So greatly diffuse the light that recognizing the object on the other side is very difficult, if not impossible. Sources of light. Natural light sources. Those coming from nature like the sun, moon, star, other heavenly bodies, lightning, fire, etc. While all these sources could now be used for photographic use from practical reason, the distinction will could be limited to sunlight only. With sunlight, there are actually several sources, primarily those coming directly from the sun, secondarily those being reflected by cold clouds or the sky. The intensity of sunlight falling on an object in open space varies depending on the weather condition, time of the day, or even time of the year. For a more accurate exposure setting at the light, only one characteristic is considered: the kind of shadow casted by an object in open space. Bright sunlight. A lighting condition where object in open space cast a deep and uniform of distinct shadow. 2. Haze sunlight. Object in open space casts a transparent shadow. 3. Dull sunlight. Object in open space casts on shadow. A. Cloud bright. Object in open space casts no shadow but object at far distance are clearly visible. B. Cloud dull. Object in open space casts no shadow and visibility of distant objects are already limited. R2. Artificial light source. Light source of this category are man-made and is divided into the continuous radiation and the short duration. A. Continuous radiation are those that can give illumination continuously. The common light source of this kind are the fluorescent lamp, incident lamps, carbon arc lamp, photofluid lamp, gas lamp, etc. B. Short duration flash unit. A flash unit gives a brief flash of light produced by a burning metallic wire, flash bulb, or an electrical discharge through a gas-filled tube electronic flash. At this time, the flash bulb is no longer available in the market, but the electronic flash remains very popular. The electronic flash offers a great light output in a compact, lightweight, and economical form. It does not have the effect of heat and glare during setup. That forensic light source. 1. Ultraviolet lamp. Ultraviolet lamp used in forensic work come in variety of shape, size, and power. Some units are portable, battery operated, and are easily carried and can meet the large and rigorous demand for field work. The ultraviolet radiation is broken down into the long wave UV, the medium wave UV, and the short wave UV. The long wave UV is used in a wide variety of applications in medical forensic. The medium wave hardening of different items for industrial application. The short wave UV is used for a variety of purposes such as to sterilize air and place of work. It is effective generally destroying many biological contaminants. Laser light application through simulated emission or radiation. Although developed years earlier, it was in 1970 that it was discovered that by illuminating certain items with laser, they would fluoresce off or could be made to stand out in sharp contrast from their background. This was especially significant locating the biological sense such as urine and saliva, as well as stains that had been washed. The laser illumination of these items been washed The laser is provided a way for criminals to finally see, locate, and visually record evidence that they know that they had been missing. The only drawback of laser is their cost. They are quite expensive. Laser is also known as current light. 3. Alternative light source. The alternative light source was developed in mid-1980 as a far more expensive alternative to forensic laser. The ELS used a variety of band-pass filters to provide a high-intensity beam of non-fluorescent light. These multiple band-pass filters allow the operator to match the laser frequency available at crime scene. Additional wavelengths were included to allow the ESL to operate at the UV near UV and IR spectrum. ELS technology had advanced to point when by using combination of filter and an adjustable iris to control the width of the transmission band, whereas wavelength from UV to IR may be deliberately selected that allows the operator to scan an almost endless variety of wavelength instead of being restricted to the expected bandpass filter capabilities. Forensic light source. The FLS is term being applied to a wide variety of relatively unfixed light sources which use filtered white light. A band of fast filter allows us a fairly narrow band of light to pass through the object is then radiated with what is normally about 400 to 500 nanometer light source. The strobe shape of the specifically developed luminescent fingerprint powder, which also falls within the strobe shape of most biological powder. This will enable criminals to search fingerprints of root surface. The white light source used white. The FLS is as simple as Megalite, Maglite type handled flashlight or spotlight with the filter in place.